Now I want to start talking about the assignment for this module. There are two challenges. You must choose at least one, but you can do both if you want to. I'm going to start with the more difficult of the two. And this is one that we talked about earlier in class, specifically when we talked about the email extraction script in Module 8. I told you that later on I was going to show you how to match that skill of extracting email addresses with a program that could traverse web pages and search for specific things. Now, a web spidering application is very, very common. We use them all the time for legitimate and illegitimate purposes. I told you that spam artists use them to harvest email addresses from the web, but Google has built its fortune on web spidering. What happens when I create a web page and I submit it to Google to be included in the search is that Google will send a web spider, a web crawler, to my web page, and it will start at the web page I give it, and it will follow all of the links on all of the pages, and it'll read the pages, and it will decide what that page is about on some level. It uses a very sophisticated algorithm to match that page with search terms, so that if I search something like Monday Night Football, it's going to follow those links. It's going to go through its catalog of pages that it's spidered, and it's going to look for pages that match what I typed in. That's how search works. And the ranking of those pages is based on Google's algorithm for determining what the relevance is. But at its core, it's just a web spider like this. Now, I can also do things like go through a website and save all of the images from that website to my computer. There's all kinds of things. Anything that you can access online can be saved to your computer. Why is that? Because every time you access something online, it's already saving it to your computer. When you look at something in Google Chrome or Firefox or Safari or whatever, or heaven forbid you're using a Microsoft web browser, if you view something using those, it's actually being downloaded to your computer in a temporary way. So it's already there. You just have to figure out how to capture it using code. And I can tell you, web spidering has been something that's been very useful for me to know from a consulting perspective. I've done dozens of jobs where companies will ask me to create a web spidering application that pulls data, even from their own websites. Maybe they're taking their website and they want to update it, but it's full of old data that they want to save. I can create a program using Python that follows the links and goes through their entire website and saves critical data for them. So this is very, very useful as a skill to have. It is somewhat complicated, but it's not that different than what we've been doing in the past. The way it's different is it's still using lots of little simple things. It's just putting them together in a more complex way. And that's sort of the trick with programming. Nothing by itself is that difficult with programming. The complexity comes when you're trying to put those things together to make them do something that's fairly complex. Even AI boils down to very simple things. So the first thing you need to know when you're creating a web spidering application is kind of a general idea of how things work in the web. If I'm sitting at my computer and I type in a web address, what I'm doing is I'm actually doing what's called a request. So if I'm typing www.google.com/something, that google.com is what routes my request to what's called a server. And all a server is a computer that's sitting somewhere in a data center that has a bunch of files saved on it that happen to be web pages. And yes, I'm super simplifying things, but that google.com server receives my request because that google.com is basically the address of that server. It's where it lives. So my request goes to that server and it says, hey, I would like this web page, please. And what that server does is it looks, and if it has that web page, it sends back what's called a response, request and response. The response typically contains HTML code. HTML code is not attractive looking, but it is what we use to create most web pages. My computer receives that code. And then my web browser, Chrome or whatever, takes that code and renders it as a visual web page with colors and fonts and all of that stuff. And so what we want to learn how to do is capture that response. We need to make the request, capture the response, and then HTML is just plain text, just like what we've been doing. So you can search through that text and you can locate email addresses, you can locate links, you can locate images, because all of those things follow a pattern. So when I go to a web page and I view it in my web browser, it might look like this. This is a very plain web page, right? And if I look at the source code, every page, if you right click on it and you choose view source, you can see the source code, which is the HTML code that you see here. And in that code, it's very easy to spot things like links and email addresses and things like that. So if you use those same rules that we used when we were doing the email extraction, but you change them a little bit to find links or find other things, then what you can do is you can say, okay, I'm going to save these links. I'm going to put them in a list maybe. Think of it like a to-do list, a to-visit sites list. So you put them in a list, and then once you finish scanning this web page, you go to the next thing in the list and you load it here, and then it pulls it up. So if you're careful and you pay attention, like if I give you a website address, let's say www.website.com, and I tell you I want you to create what's called a sitemap of all of the pages in that website, you can do that because what you can do is you can follow the links from page to page. And anything that's not www.website.com, you can save that link, but you don't want to follow it because then you're going to a different site. So if you do this and then you follow a link, say to like Google or the New York Times or something like that, then all of a sudden you've opened up a whole new site full of links. If you don't stop at the links that are on that website by checking what the domain says, then you'll end up spidering the whole internet. You'll basically turn your computer into a Google spider bot. So that is challenge number one. Let me show you a little bit of sample code that I've included for you. And if I go to the web crawler here, okay, there is the sample code for URL library module, and you can download that code, right? It looks like this. And you can take that code and copy and paste it into here, and it looks like this. Now, I'm not going to go into a huge amount of detail, but I'm going to show you what the code means. There's kind of three parts to it. The first part we've got here is importing these two libraries, the URL library.request. Request should sound familiar because we just talked about that. And SSL is a security protocol, right? So we need both of those things because we have to do something special or else the web server is not going to give us a web page. Why is that? Because web servers don't want to just give up their data. If they do, if they don't screen who gets data and who doesn't, that leaves them very vulnerable to hacking attacks. And there's certain kind of hacking attacks called a denial of service attack, in which you write a bunch of little programs like this and you put them on computers all over the place, maybe hundreds or thousands of computers, and at a certain time or day, all of those computers start asking for web pages all at the same time. and it just brings the server to its knees because it can't handle all of those requests. That's called the denial of service attack. So to prevent that, there's a minimal level of security that web servers create. And they say, we're only going to give up a web page if you're an actual web browser, like if you're using Chrome or if you're using Safari or whatever. Fortunately for us, that is really easy to get around. And the way we get around it is that we are creating a program that actually pretends, just in time for Halloween, dresses up as a web browser and says, hey, I'm a web browser. Give me the web page. And then it just does it. I don't know why it takes our word for it, but it does. So this first part, these 3 lines here, are using SSL module to create what's called a security context. All that means is that we're creating a secure connection with that web server, which is one of the pieces of that getting past that security or masquerading as a web browser. This is the web address or the link that we're going to use to start. I created this as a fake set of web pages on my website specifically for this challenge. Okay, that'll bring up this, and this is me a long time ago in Haiti with some friends of mine, and it's got some links on there, and it's got some other stuff going on, an email address. And if I go in here and I choose view source, let me see if I can make that larger. I can. Okay, so there is the actual source code of that web page. And you might not understand HTML, but as you look through this, you're going to see some things that stand out to you, that make sense. Some email addresses, some links. Here's an image, right? So those are things that you could potentially teach your algorithm to look for. So that's the page. And I'm using it as a string variable because you want to be able to change that and then feed it back into this code here. So there it is, str URL. And you can see I'm using URL library request to create a request. And right here, headers equals user agent. What does it say right there? It says Chrome and a specific version of that web browser. So I'm actually dressing up as Google Chrome today for Halloween. And I'm using that code or this version to tell the server, hey, I'm Google Chrome. Give me the web page. And you can see here, I'm also adding CTX, which is that security context. So those are the 2 pieces, telling it who you are, providing the security context. And now, page, read, decode. I'm basically getting the result, decoding it using a certain character set, and putting it into a string. Now that string contains that exact code. So if I run this right now, it will actually go out. It's reaching out to my web server, waiting for the response, and in just a second, it's actually going to print out the HTML code that it receives. So now you can use this code, if you structure it within your own code, to follow those links. Okay? So that is file challenge number 1. And that is the more difficult of the 2.